All right, so there's real and imaginary roots. We're talking about review here. We're reviewing for the final, and mostly we're talking about factoring and quadratics. And that brings up the topic of, is it real or is it imaginary? And of course, the leprechauns in a pot of gold have been a classic thing that was imaginary. Of course, for keeping it real, Snoop Dogg would be a perfect example. It's all right, so Snoop Lion. He has talked to the lady in the Bahamas who told him he was more of a lion, so he's now Snoop Lion. No, serious. Yes, and he's apparently going with sort of a gangster slash Rasta kind of a deal. So he's like sort of not rap, he's sort of rapping and sort of doing a yeah, like a Bob Marley kind of a deal, like reggae rap kind of deal. So anyway, so he's keeping it real for us. That's where it touches. See, your parabola would touch like this or like this, or even a parabola that touches just once like that. As long as it touches the x-axis, it's keeping it real. If, on the other hand, it's imaginary, kind of like this. I made that caption, kind of made myself laugh when I did it. But anyway, there's a little kid who's pointing at this thing, and it's supposed to be like the Loch Ness Monster. Can you imagine if you're in your boat and all of a sudden you saw that on Lake Minnetonka? Square root of -1, what's that? I, which is what? Which is, no, square root of -1 is an imaginary number. See, it's imaginary. Okay, anyway, so the imaginary thing is, can you imagine, again, seeing that in Lake Minnetonka? It would just freak you out. I saw something really big like that one time in the Boundary Waters. The biggest fish in Minnesota, you know what it is? Nope. Sturgeon. If you've ever been to have you been to the State Fair and looked in the giant pond? You've never looked in the giant pond at the State Fair? How many of you have not ever looked in the giant pond at the State Fair? Oh my gosh. Okay. You gotta go look. Why don't see if anybody's got a picture on Google of the fish pond at Minnesota State Fair, because and maybe somebody's even recorded a video of it before. There are all these fish from Minnesota. They're all Minnesota fish that they put in this pond, and it's clear on the bottom, so you can actually see all these fish swimming past. They're all the Minnesota kinds of fish. And there are some really big ones, and the biggest of them all are the sturgeon. They're the DNR. They're in charge. They take care of these fish. So they actually think that the value to, it's sort of like the whole zoo thing. Yep, there's a paddlefish. And the they think there's value enough, sort of like in a zoo. Why should we have an animal in a zoo? Because shouldn't they all be out in the wild? And I guess the logic is that at a zoo, you've got a chance for people to get to know the animals and maybe like them enough so that they don't want to destroy their habitat and stuff. So now you went to food on a stick. No, they just take them in there for a little while and then they release them. So basically the idea is we'll catch a bunch of Minnesota fish, let people see what kind of fish are swimming around here in Minnesota lakes, put them in this little pond for the week at State Fair, and then they go drop them back in the lakes. So anyway. Sturgeon are huge fish, and they're really old. They can be up to 200 years old. Can you imagine a fish that's like twice as old as your grandpa? That is a sturgeon. Very good. Here, I'll just hold it up. There's a sturgeon. Yes, ma'am. Mr. K, are you doing what we're doing? Good. Okay. All right. Yes. Yes. Not dangerous like they'll kill you, but they can bite you. Bullheads have pointy things on their fins that they aren't going to like swim up to you and poke you on purpose, but if you were to step on them, they have really sharp pointy thing, one on top and two on the sides, and they really hurt. They get some kind of like a poison or something. Yeah. You've had bullhead sting you before? It really hurts. I haven't stepped on one, no, that would be awful. Because just getting poked by one quickly in the hand. Anyway, and there's other fish that have spines on them. A lot of fish have spines, like walleyes have spines on the top and sides. As far as the dangerous fish, I would probably pick the muskie, just because it's really rare, but it happens that muskies will bite. Like some kid who's like swishing their toes around in the water, you know, like they're just trying to like wash their feet off or whatever. Every now and then, people get bit. Um, the probability in Lake Minnetonka, I'm guessing it's probably only happened twice in the last, like 20 years. But every now and then it happens, and there's news shows. What's weird that has happened recently, though, is, and I know I'm recording this, and that's okay, is that there have been attacks by otters. People have been swimming across a lake. It's usually like long-distance swimmers who have been attacked by otters and have been bit like 20 or 30 times before they can get to shore. Can you imagine? Not in Lake Minnetonka, but Minnetonka would have otters in it. So there's a chance that that could happen. Can you imagine you getting bit by this furry thing that can swim really fast? And they don't know why. They think maybe they're protecting their young or something. But anyway, these are all things that are really, really rare. You don't have to worry about that. Okay, this slide was about imaginary things, and we got off on that topic because of Mr. Imaginary thing right there, which is supposed to be the Loch Ness Monster, and my guess is it's actually a whale, because it looks like a whale. It's just surfacing, is about to flip its tail up in the air, but it could be wrong. Could be the Loch Ness Monster. All right, these are imaginary ones because they don't touch. They don't touch, so therefore they have imaginary roots to them. All right, let's move on. We're going to go through factoring from easy to difficult. This is the easy kind. Now, you do not have these notes on your iPad, unfortunately, but you can still follow me. Get into paper report, not paper. That's not true. Get into Remarks, the Remarks app, and I'll factor this one. I can handle it. 3 goes into both of them, and I'll go 8x plus 6, and then hopefully you'll realize what? I should factor it even more. So really 3 wasn't a great thing to take out, because now I got to take out something else. 3, and then also, what else comes out of this? A 2. And then the 2 would come out, and I'd have 4x plus 3, and that's okay, but then I could have just factored, see, the 3 times 2 makes a 6. I could have just factored a 6 out in the first place, and it would have been fast. All right, moving on. Would you please factor that one? Yes, that was factored as far as I could. You factor this one, please. Now, in a moment, I'm going to have you turn your iPads so that I can see them. I would like you to select a thicker marker than normal because it's way easier to read. You might end up liking it. And then I'd like you to turn your brightness up a bit, just for the next few minutes. It won't take that much battery. Over the long haul, it's probably smart to keep it kind of dim because it saves battery. But for the next like 5-10 minutes, have your brightness up. If you don't know how to do that, just double tap the main button and then swipe once to the right, and you'll see your controls for brightness. Otherwise, you can go ahead and set it. Not all the way up. Just make it kind of at least medium bright. All right. Would you show me what you have got for this one? All right. I see one person with it wrong. I see many with it right. The right answer is the 2x and then x plus 2. A few of you made a mistake on that last one. 2x and then x plus 2, because if I multiply this out, that times that makes that, and that times that. All right, move it on. This one is different because it's got 2 things, but yet you can still factor it with 2 sets of parentheses. Do you remember what you get? What is it? X and x and minus 4 and plus 4. And it doesn't matter which order, but now, could I do this if this had been a plus right here? No. It only is called difference of squares. So you can't factor it if it's a plus, unless you use imaginary numbers. Let's do one more that's normal first. X squared minus 36. That'd be x plus 6 and x minus 6, right? So I'm going to make it a little harder. I'll throw in a 4 here. See if you can factor that. I bet a lot of people are going to do this wrong. Give it a shot. All right, I'm not going to ask you to show me because I know a lot of you are going to people have done this. 2x and 2x and plus 6 and minus 6, and that's wrong. Why? Because there's still a 2 in both of them. Or you could say that I could have factored a 4 out at the beginning because they're not factored all the way that way. So take the 4 out at the beginning and you'll have 4 and then x squared minus 9. And then what would I have? 4 and then a parentheses x plus 3, x minus 3. You got to get good at factoring all the way. You learned factoring in 7th grade, for Pete's sake. So this is not, you shouldn't just be factoring anymore. You should be having to handle the trickier stuff like that. All right, moving on. This one's just a plain old-fashioned factoring, except you're going to find out it doesn't factor. What's it called when it doesn't factor? Something that doesn't have factors is called something. Nobody said it yet? Nope, none of the above. Nope, none of those answers. Starts with a P. Nope. Nope. So name every math word starts with a P. How about you just think about it for a second? Something that doesn't have factors. Prime, there it is. A prime number doesn't have factors. See, if I had the number 17, it doesn't have any factors except for 1 and 17. Okay, so these are, when they don't factor, they're called prime. You just write prime. Or you pick the choice, if it's multiple choice, that says prime, if it won't factor. All right, moving on. This one goes into everything. So factor the 6 out, and then factor it again. And then see if you can factor it again. Factor it as far as you can. And in a moment, when it's all done, I'd like you to show me without turning it. Make sure your iPad is turned so that I can see the whole answer that you have. Mr. Paper Guy over there, I'll shift yours up close. Ooh, are you using calligraphy or are you just doing that? It's very cool. All right, show me. Good. Good, 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 good. Don't know if it's good. Good, 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 good. What were you doing? Oh, blame the iPad. Good, 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 good. Get started. Not done yet. All right. Everybody had it right, which was 6 came out first, and then you'd have x squared plus 4x plus 3, and then you go 6, and then x plus 1, and x plus 3. Okay, why do we even do this? Because it gives us the roots. And the roots are like really, really key things. They're called 4 things. They're roots, solutions, x-intercepts, and zeros. They're really, really important. And they would be -1 and -3. The easiest way to see it right now is that they're zeros, because they make the equation 0 if you put them in. All right, moving on. That's a 4-part factoring. Abraham Lincoln said, a country divided shall not stand. A house divided, you're right. But he was talking about our country. So I'll paraphrase. And what he was trying to say was that we can't take our country, split it in half, and be like the north half of the United States of America and the south half of the United States of America. We won't really stand. We'll end up just in a fight with each other. And fight we did. We had the Civil War, and it was brutal. Has anybody seen the movie Lincoln yet? I liked it. It was a really good movie. It depends on your opinion. If you don't like history at all, you probably wouldn't like it, because a lot of it's the history of. Because it made me realize that. No, he's got. Don't do it twice, please. I think from now on, the person who is the second person to try to bust me on the 10. Oh, it was me, Candy. All right. So, this one you have to divide and conquer. So we're going to divide this down the middle, and this is a really good kind of factor. And it's good to know you use it again in pre-calc too. They need you to be able to factor 4-part things there. So x squared comes out, and what do you got left? X plus 3. And then 4 comes out, what do you got left? X plus 3. And of course, they're the same. This and this need to be the same to keep going. Because if they're the same, then just like we factored a 4 out of this and this, we're going to factor an x plus 3 out of this and this. And those two together come to the front. X plus 3 comes to the front. And what do I have left when I remove them? Or what I'm really doing is dividing by x plus 3. Dividing by x plus 3. And it makes them cancel. And what I have left is x squared plus 4. There we go. Raise your hand if you got that one right. Now, one kid said, couldn't we have used synthetic on this? And yes, the answer is yes, you could have. If you had a calculator, what would you have done first? Graphed it. And after you graphed it, what would the calculator have told you? One of the zeros was what? Would it have been able to tell you this 0? No, because that's imaginary. It would have told you a negative 3, and then you would have done synthetic. I want you right now to do synthetic. To put the little 3 in the little box, and then write down the other numbers for this. I'll get you started in case you forgot how this works. You know that negative 3 works because you saw it on your graph. And then you put in 1, 3, 4, and 12, and you see what happens. Give it a shot. You got to know this because there's like 4 big hard factoring questions on this test. And you'll need to be able to graph it to see where the root is, and then factor it from there using synthetic. Once you graphed it, it just tells you that negative 3 works. Then you use this system here to see what the factors are. Drop it like it's hot. Multiply it. Add it. Multiply it. Add it. Multiply it. And add it, and equal to 0. So since that equal to 0, it worked. And therefore my answer is, drop this down, x plus 3, and then what's in here ends up being an x and an x squared, and 0x's doesn't really do anything right, so I can get rid of that, and there we go. It's the same thing we had before. Do you remember that? Alright. If you remember that, you should be able to do this. Use your calculator to see what one of the roots is. And in fact, your calculator will probably tell you 2 different things that are roots. You can't do them both at once, but pick one of them, do synthetic, and then if it tells you another one that would have worked, you can do synthetic again. And you'll be able to factor it further. So, use your calculator. I'm going to give you a minute or 2 to get this one done. And then if you're having trouble in it, ask me. I can explain how to do it. Okay, so most of you guys found that your negative 1 would work. And so if negative 1 works in here, then I can go like this. Negative 1, 1, 4, 7, 16, 12. Draw the line, drop it, multiply it, add it. Oh, there's so many different steps. Multiply it, add it, multiply it, add it, multiply it. It worked. So, and my answer is this. X plus 1 for that part. And then this part, this is the x squareds, x cubes, plus, plus, plus. That's really actually pretty hard factoring. Now this part right here, you can divide and conquer on if you want. Or you can say the other thing that worked in here was negative 3. So now on this part of it, use negative 3 to do the synthetic. 1, 3, 4, and 12. Drop it, multiply it, add it, multiply it, add it, multiply it, add it, and it worked again. So then now I bring this one down, x plus 1. I bring this one down, x plus 3. And then this part right here, this is the x's and this is the x squareds. 0x's is kind of inconsequential. And there is my answer. How many of you feel confident you can do that? Good. So the final has a bunch of factoring. We've talked about all the different kinds now. And your answers, when they are factored, then come out to either real or imaginary. So you just need to touch on that for a second. This one is the real kind. because that would be a touch at 7 on the x-axis. This kind is the imaginary kind of answers. Why? Because when I actually try to figure out what makes this 0, when I subtract 5 from both sides, I end up with this. Is that even possible? Something squared equaling a negative? You can't do that. That's why it's absolute value of x equals square root of negative 5, and then to get the absolute value off of there, I say x equals plus and minus the square root of negative 5. That is an imaginary answer, because it's a square root of a negative. All right. On this one, would you get real answers or imaginary or some of each? False, not some of each. Only real. This one comes out to be negative 5, and this one you can make it equal 0 by putting in something. You know what? If you don't know what off the top of your head, because something squared isn't going to equal 8 really nicely, you go x squared minus 8 equals 0, x squared equals 8, now what? So final answer is plus and minus what? Square root of 8. In which, yes, you could simplify that if you wanted to. Root 4 and root 2, which would be 2 root 2. So yeah, you could say x equals plus and minus 2 root 2. Now, some people are like, how is that not imaginary? Because there's no negative under the square root. Square roots are okay. It's just negative square roots that we don't like. So that was real roots, and so is this. X equals negative 5, that's a real root. Only if I'd have a square root of a negative would it be imaginary. So often kids had put this, there was a line for real answers, and there was a line for imaginaries. And I think some kids thought whenever there was a square root involved that I should throw it on the imaginary line. I had to mark those wrong, because they aren't imaginary. If it's like square root of 2, that's not imaginary. It would only be for the square root of negative 2. That would be imaginary. Okay. So just make sure you're only putting on imaginaries. You're only putting the things that have square roots of negatives. A negative on the outside is okay. It's not imaginary. Like this. That's not imaginary. That's real. It's a decimal. It's a negative. And that's okay. You can't have this. That would be imaginary. Okay, moving on. I discovered that topic, and that is our last one. So your homework is take the next page in the packet, which is page 5, I believe. And then we have Monday's review day, which is going to be on the easier side. I have one last thought for you.